welcome back. Today I briefly, or maybe not so briefly, want to talk about the chip called 74HC595. It's a serial register, shift register. It's also a binary memory chip. So what can you do with a binary memory chip? Well, one thing you could do with it is control a light crossing or intersection with lights. So imagine this as an intersection. I have one road's worth of lights. I got red, yellow, green. Another road, red, yellow, green. So I can use this chip, it's actually right there, to switch these on and off at will. Of course I could use my Arduino directly, but the thing is, this chip is controlled only with 3 wires. 3 wires. That's very impressive. Of course we're going to ground it to the Arduino and we're going to pull 5 volts. Of course, if you're doing large projects, I do not recommend pulling power through the Arduino. I would use a external power source for the driving the circuit. So before we go into the actual hardware and example of the use, let's talk a bit about what we need. First of all, we need some programming code, but we also need to know about this chip. We need to know how to hook it up. So the first thing I do when I get a new chip on my hands or any sort of circuit, I pull out the old Google. And I do that because I need to know the layout of the pins, I need to know the chip's limitations, etc, etc. In our case I know the limitations, and I just need to rememorize the layout of the pins. So let's do that. So here we have Google. Let's type 74. Oh, it's already there. Easy peasy. And we got some data sheets linked. We got some examples down here, but what I really like is this one right there. Arduino shift out. Sure, that's the thing. If something is linking to the Arduino, I usually always use that. So let's see, what do the Arduino type say? Well, they talk a lot, as usual. So let's just skip down to what's important, and this is important. They type in the middle 595, and that's because they are using a Philips datasheet. That doesn't matter. I know the 595 chips are usually in the same layout. In my case, I have exactly the same layout as on the screen, so I'm happy. Notice the marking identifying pin number 1. In my case, I have a U up here. That U also represents that to the left of the U, I have pin number 1. So, what's important? What do we need to know right now? Well, first of all of these Q pins, Q1, 2, 3, 4, 5, 7, and this single one over here, Q0, are my output pins. I have voltage, I have ground, I have something called Q7 with a small star. Well, that's because if I wanted to, I could connect these in series, so I could have another and another, and I could program them all still only using 3 pins. So what are the pins we need to connect to the Arduino? Well, the first one is this one, port number 11. You can see 11, it's right there. SHCP, the shift register clock pin. The next one is the STCP, the shift storage register clock pin, or the latch pin if you want. And the last one is DS, which is serial data input. So how does this work? Well, it's quite simple. When I have 8, that's 10, yeah I know, so 8 pins available to me. If I want to turn pin number 3 on, the way it works is I'm going to send numbers through the serial input to this one, and I'm just going to send 1. Then in order to move the 1 over 2, imagine you are pushing them in from the end of the chip. So the first one you take is 1 and you push it in. Now it's on Q0. That's no good. I wanted it on Q4 maybe. So next thing I do is push in a 0 and another 0 and another 0. Okay, so now it says 0, 0, 0, 1. And that's how I place my ones. And all you really do with this chip is place ones and zeros in a certain order, and you can change them accordingly. And this is where the Arduino gets really smart using the shift out command, because you can change, well, I have 8 zeros, I want to change this 1. Okay, then I can send in the binary code or value for this 1. So if I'm using MSB, which means the most significant bit first, which in my case is over here. So I'm counting 1, 2, 3, 4, 5, and you need to count in reverse, right? Then I want to change bit number 4. So bit number 4, actual value is 1, 2, 4, 8. So I want to change 8, so I just send the shift out command 8 to my chip, and then it's just going to jump to 1, 2, 3, 4, 8 and shift that one regardless of its previous value. It's going to turn it around. That's how we're going to program it. You can use different methods if you want. I'm going to flip them ones and zeros like that. Luckily, all of this have Arduino made really simple for us, so we just need to tell it which to flip. No programming skills required. They got a command that allows everything to work just like that. So we connect our pins. I'll go through the connection in a minute. I think I got it somewhere. If I might accidentally have closed it, that's silly. Yeah, nope, there we go. Here we go. So the way I have my setup connected is, as you can see here, I got my chip and it's flipped upside down, as you can see. So in this program you can hover over the buttons and you can see the names. So ground is of course grounded. MR is grounded because in the Arduino, let's do this right here, it says to be low, and below is the same as grounded. Then we have our SHCP, which we are connecting to port number 4. STCP I have connected to port number 3. DS, direct serial, connect to port number 2. Of course this one is grounded in the middle, OE, sorry. And the red one is a VCC, which of course is power. So right now I only connected one LED in this schematic. In my actual board I have connected several, but it's similar. I have just used several of these ports over here. And just remember, this single one is actually port 0, port 1 over here. So you have all 8, even though it ends on 7. So that's all we need to know. Now we just need to head right into programming our shift register, and once we are done programming we are able to run the program, and we're going to build our example, of course. So the code, this is not the code, this is not the code, this might be the code. There we go. I have a program, of course I'll make that available in a link below. First of all, I define my pins, my latch pin, my clock pin and my data pin. I make a small note so everybody can see what they are called. I got some times. This is Danish for long time, this is Danish for short time. Right now the times are the same, so they are indifferent. And that's the time between the light cycles. I prepare a number called number to display, and this is effectively the output from the Arduino to my chip. And right now I want to output 0, but I'm not sending anything yet. There's no command. I'm just preparing a integer. Next thing, I have my voids set up. I prepare my 3 pins. That's these up here for output. I have a serial connection, and that's just because I have something like this which are telling me feedback through my serial connection up here, my serial monitor. I'm not interested in serial feedback in this example. I just use it when debugging. So it's not needed, but it's useful for debugging. So the first thing I do is actually call a command saying update lys. That's Danish for update light, and I'm sending the number 4. So before we go to the main loop, let's jump down and see what's going on here right away. And here we have our function called update light, and we're getting an integer called light. So we are switching using the command switch, means when we receive a number here, go to that number and execute that function. We were receiving number 4, which is down here. You can see it says case number 4, and means I'm going to flip binary number 3. And the way I'm going to flip it is saying number to display. If you remember, upstairs it was 1, 2, 3, 4, 5, 6, 7, 8 zeros. And then we're going to flip binary number 4. This is XOR, meaning flip the number 4. And when you type 4 in binary, that's actually spot number 3. Don't need to understand it, you just need to know it. And you can see I've written the numbers right next to, so it should be comprehensible, right? So when I want to switch this one, I write 16. When I want to switch this one, I write 32, etc. If I wanted to switch them all, I would write 255. Now, there's one thing to remember. If you switch all and it looks like this before you switch, then your switching will result in this. It's not a reset function, it's a switch function we are running, except it's not called switch, but you just need to know how it works. It's going to flip the value from 1 to 0 or from 0 to 1. That's all we're doing. Okay, it was number 4. So right now the value is 0, 0, 0, 0, 0, 1, 0, 0. Okay, we break the loop, move down here, and then we digital write our latch pin. The latch pin really prevents any data from coming into the chip until it's turned low. The latch pin is, let's see, latch pin is this one. It's on pin 12. It's called STCP. STCP. Come on. There we go. So this one is usually high, but then we turn it low. Back to code. Then we're going to use the new Arduino command called shift out. We're going to shift out on the data pin, the clock pin, and we're just defining them for this command, so it needs to know the data pin, the clock pin, and which binary bit is the most important. It's just the order. There's also called a function called MSB last. We're using first because we have been programming in that, and we have our hardware, which means our wires from the chip to the lamps, set up so we know MSB first is the way it works. You can do what you feel like, but this is just how I set up my system. And finally, the new number, which in our case is 100. It's not 100, it's actually 4, but it looks like 100. Then we're going to set the latch pins to high, and we're done. That's it. We will go back to the main loop, and this is basically our light cycle. We're going to ignore these lines here called besked. It's a Danish word for message, and that's just serial feedback. But the row, if you imagine this part as a row down like that, that's one road, and this row over here is another road. So we got two rows of light switching. And since we already turned one row to red, I know it's red, but we switched one pin on the board. The next command is going to turn the other one to green. And let's see right here. So let's expand your knowledge a bit. Red, rød means red, gul equals yellow, grøn equals green. That's Danish and English. So now you know what these commands down here is. Red, red, green. So we switch green on, we switch green off. We switch yellow on, we switch yellow off. We switch red on, and then we switch red off on the other one. So we got our two rows right down here, and we just continue the loop over and over and over. And you can see in between we have these delays. So this is where you should define your wait time between each cycle of the lamp. That's basically it. That's all there is to it. There's nothing really new. The only new thing in our coding is maybe the switch. I can't remember if we went through it before. And of course the shift out value. If you need to know more about the shift out value, I recommend reading this entire page right here on the Arduino website. They have a pretty good explanation and some awesome examples where they even use two chips, as you can see. So let's head over to some practical engineering if we want. We're going to test this with our Arduino. So uploading to the Arduino and connecting it. So let's see how that's going. Okay, here we go. I got my Arduino set up right here. Got my breadboard. The yellow wire is 5 volts, the blue wire is ground. The 3 wires are connecting to the chip, the 74HC595. And I'm using the ports directly in order, so 2, 3 and 4. Port number 2 goes to DS, which is the serial input. Port number 3 goes to my STCP, that's the shift register clock pin. And port number 4 goes to my latch pin. It's also a register clock pin, but it's the storage clock pin. This is the shift clock pin. Okay? We don't need really to worry about this. We just need to know the names so we connect them correctly in our programming code. The chip itself has a small dent in right here. It's cut or pre-made from the factory. And when I have it right here, I know, when I have it on my right side, I know the one up here is port number 1. From the diagram, I know the first port I can use as an output is over here. That's this one, this orange wire. It's right next to the DS pin. So I got it hooked up way over here to the first LED. Then I move over here and I got it up to the next LED, and you can see I have 3 orange in total and 3 LEDs over here. Then I have 3 yellow wires connected in row, and they are hooked up over here. Of course I got some resistors, and the resistors are just grounded. So power goes to the wire into the resistor into the LED. The same for the orange. So this symbolizes one road and this symbolizes the other road. The shift register is also hooked up with power in 2 spots. As you can see, it might be hard to see, but there's a yellow power connector right there and one right there. It's hooked up to ground right there and over here. And we already discussed the code, so all we have to do now is hook up power, and it should work. So let's see. They're all lighting up, but now we got green and red. Now we got yellow and red. Red and red. Red, yellow. Red, green. Red, yellow. Red, red. Yellow, red. Green, red. So that's one cycle. So the only thing we need to really manage now is the timing interval. But that's easy. That's just adjusting the timing, the code. So how about that? A very easy way to control a light signal using a simple chip, a simple expansion chip as well. It's basically a memory. One more thing. These chips can be expanded, so let me disconnect this. Imagine you wanted to control more than maybe 6 or 9 LEDs. Maybe you wanted to control way more. Then this chip has an output port. It's called, well, it's really just called output and serial out. It's on Q9, so we got our dent right here, and then it means it's this one, the last one, offset port 1. That I can put into the input of a chip more, so if I placed one more right here, so something like that, I can connect the output to this input, and I would have even more outputs to control. It's really that simple. The only thing I needed to change in my code was the number of inputs we had. The numbers, remember those? We would just have to double up for each amount of chip we add. It's really that simple. And that's basically just how we can control it. Very simple, or control a lot of LEDs with basic memory modules and a Arduino. And remember, it doesn't have to be an Arduino. You can also use a PIC or any sort of microprocessor, and they're all relatively easy to program. The only thing that really differs is some of them do not allow USB connections directly. Well, that went well. It was working as expected. And what else is there to say? I can't imagine not knowing this chip. It's very important and used in many applications, and you could actually use this as a primitive sort of memory. And of course you can expand it to 8, 16, 32 bits, even 24 bits, yeah, if you want to move in the middle area right there. And that's actually also how your memory in your computer works, except it's not just 8 bits. We're talking millions of bits and much smaller size, but it's the same theory that's going on right now when watching this video or playing a game. It's just much faster. Next time I want to talk about this chip. Yeah, looks exactly like the one we just had. It's a bit different if you have worked with radio controlled cars, remotely controlled cars, toys with multifunctions. I'm almost certain one of these are in there, because with this you can exclude many microcontrollers in controlling devices such as remote controlled cars. I will now read the value if I can see it. Well, I turned it upside down again. There we go. The chip name is L293D Delta. So, next time we're going to talk about that, and if you want, you could Google that name I just read up and see what it is, so you are prepared. If you have any questions, comments, or rating, leave it below, and I'll see you next time. Bye.